Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening.
Good evening. So in response to the message, which I had posted on WhatsApp regarding your annual examination timetable, most students had, I got to know the timetable, the final examination timetable of most of the schools. At least one student from, each school had texted. So all of you, most of you are starting your final examinations next week. Some on Monday, somewhere around, the 22nd or 24th, 25th. So I thought, let me just touch up with probability also. Polynomials was covered already in term 1. So we, apart from circles, we are coming to the end of circles. We've done, many extra problems also from this chapter circles. We have the last exercise 10.5. That will be about 45 minutes. So we have that in circles, exercise 10.5. Apart from that, we have probability and constructions. So constructions, what you could do is, before your exam, you could just get in touch with me and get your doubts clarified. Go through whatever your, what you've go through whatever you've learned from your teacher in school, from school. And in case you have any doubts with construction, we could just sort it out before the day before your exam, your math exam. So that way I can help you all, personally with your doubts on the chapter construction. Probability is simple. I think today's class we can do most of it. So this week we'll have, so we have today's class. So this is Wednesday, and then Saturday and Sunday. Then I think after that, all of you will be busy. I want all of you to attend the class till Sunday. Do not miss the classes because your exams are starting next week. Don't miss the class on Saturday and Sunday because we have that little more in circles to do. So with probability, most of probability, being completed today. And the rest of circles on Saturday and Sunday. We don't need that much time. So we could do some more, some revision on polynomials maybe in the class on Sunday. So please don't miss the class on Saturday and Sunday. Yeah. So I was just trying to give the reason why suddenly I'm jumping from circles to probability. I thought, we'll just have a look at this chapter also, as your exams are happening soon. All right, children, please go through the slide. Please go through the slide. Okay, so I hope you're finished till here, from here to here. So this word probability, probably, as it's used, probably is maybe. You're not sure. You're not sure of something. I may probably attend school tomorrow. You're not sure. You have some reason for not going to school, but you're not very sure. You may or may not attend school. When you're uncertain about something, you say you use the word probably. When you're not sure, when you're uncertain about something, you say probably, maybe. So probability is defined as a numerical measure of uncertainty. To find the probability of the happening of an event, we use this ratio, the number of favorable outcomes by the total number of outcomes. Number of favorable outcomes by the total number of outcomes. We say that the probability of an impossible event is 0. If an event is impossible, meaning if an event cannot happen at all, then we say its probability is 0. For example, the event of, this is not the only example. This is one example. The event of getting a number greater than 6 on rolling a die is an impossible event. So the event of, because you know, a die has 6 faces. It has 6 faces with dots on each of the 6 faces. There's 1 dot on one face, then 2 dots, 3, 4, 5, and 6 dots. So when you roll a die, the die does not show up any number, but you count the number of dots. So when you roll a die, the number of dots on the face of the die can be 1, 2, 3, 4, 5, or 6, but nothing greater than 6. It can be 6, but nothing more than 6. So the event of getting, when you roll a die, the event of getting a number greater than 6 is an impossible event. The probability of a sure event is 1. So the probability of an impossible event, of an event which cannot happen at all, is 0. The probability of a sure event is 1. If an event is sure to happen, it's certain, it'll definitely happen. The probability of a sure event is 1. For example, the event of getting a number less than 7 on rolling a die is a sure event. You roll a die. What is the chance that you will get when you roll the die? What's the chance that you will get a number less than 7? You will always get a number less than 7. Now don't go to negative numbers. Don't say you will not get -1, -2. So when you roll a die, you may get a 6, which is less than 7. You may get 5. You may get 5, which is less than 7. 4, less than 7. 3, less than 7. 2, less than 7. 1, less than 7. So the event of getting a number less than 7 on rolling a die is a sure event. You will always get, when you roll a die, you will the number of dots on the face of the die is always less than 7. It's always less than 7. It's a sure event. So the probability of a sure event is 1. We say 100%, right? We say 100%, 100%. 100% meaning 100 by 100, which is 1. So these are the boundaries of the probability of the happening of an event. These are the boundaries. The boundaries are 0 and 1. If an event cannot happen at all, its probability is 0. If an event is, that is, if an event cannot happen at all, it's impossible, then its probability is 0. If an event is certain, sure to happen, certain, it will definitely happen, then its probability is 1. The probability of the happening of all other events will lie in this range, 0 to 1. Can be any value between 0 and 1. So the probability of the happening of an event can be 0, can be 1, or anything between 0 and 1. The probability of the happening of an event can be 0, can be 1, or anything between, or anywhere between 0 and 1. It cannot be less than 0. It cannot be greater than 1. So supposing there's a statement, the probability of the happening of an event A, the probability of the happening of an event A is 6 by 5. Is the statement true or false? Let me write that. Am I clear, children? Am I audible and clear?
Yes, ma'am.
Okay. The probability of the happening, the probability of the happening of an event A is 6 by 5. We need to comment if this statement is true or false. Yes, can anyone try this? It's numerical. 6 by 5 is, see, probability is a numerical measure of uncertainty. It's a number. 6 by 5 is a number. Is this statement true or false? True, false, or not sure about the answer?
False.
False. Who's that?
Hitesh.
Hitesh, why?
Ma'am, because a probability can only have a like fraction, ma'am. This is an unlike fraction.
No, you're confused with the terms. Like, unlike, fraction, no. Some other fraction. Not like, unlike. The probability of the happening of an event can only be a proper fraction. It cannot be an improper fraction, correct?
Yes, ma'am. Yes, ma'am.
Yeah. Because the boundary is, it can be 0, it can be 1, or anything between 0 and 1. And we know that the value of an improper fraction. Okay, what is 6 by 5? Why so much of?
It
What
is
is 6
more
by
than
5? 6
1
by
point.
5 is 1 by 5. It's more than 1. 6 by 5 is 1 by 5. It's more than 1. If it's a sure event itself, the probability is 1. Then how can the probability of the happening of some other event? There's nothing more than a sure event. There can be nothing more than a sure event. The probability of a sure event is 1. And there is this event whose probability is more than 1 by 5. So the statement is false. The statement is false. It can be 5 by 6. It cannot be 6 by 5. 5 by 6 is the proper fraction whose value is less than 1. We have seen this in 4th standard. No, we all know this. The value of a proper fraction is always less than 1. The value of an improper fraction is always greater than 1. So the moment you see an improper fraction, you don't have to find its value. If it's an improper fraction, the numerator is greater than the denominator. Its value will be more than 1. Can the probability of the happening of an event be 203 by 165? You don't have to find its value. You know it's a improper fraction. It's an improper fraction. Its value is greater than 1. It'll be more than 1, the value of this fraction. The mixed fraction is more than 1. So not possible. This is a fraction. It's a valid fraction. 203 by 165 is a valid fraction. But this fraction cannot represent the probability of the happening of any event. Okay, so what we understand is the probability of the happening of an event can be 0, 1, or anything between 0 and 1. So anything between 0 and 1, meaning it can be a proper fraction, not an improper fraction, because the value of an improper fraction is greater than 1. So we say the probability of an impossible event is 0, sure event is 1, all other probabilities lie between 0 and 1. So that's what is expressed in this inequality. That's what is expressed in this inequality. 0 is less than or equal to P of E. Probability of the happening of some event E is less than or equal to 1. How do we, let's understand this one. Let's understand this. Now, when we say A less than B, The other way of writing this is B greater than A. Okay, 10 greater than 6. 6 less than 10. The inequality is reversed when you exchange the places. The inequality is reversed when you exchange the places. Now, when it's an equality, we say A is equal to B, B is equal to A. In the case of an equality, even if you exchange it, it's the same. A is equal to B, B is equal to A. But you cannot do that with an inequality. 3 is less than 4. 4 is less than 3. No, 4 is greater than 3. So when you work with inequalities, when you shift, when you shift like this, when 4 comes to this side and 3 is taken to the other side, the inequality is reversed. The inequality is reversed. 20 is less than 25. 25 is greater than 20. Okay, so what have we understood? The probability can be 0, anything more than 0, or less than or equal to 1. It can be 0, it can be 1, or anything between 0 and 1. So the probability of the happening of an event will be greater than or equal to 0. Yes or no, children? Can I say this? The probability of the happening of an event, wait, we haven't completed. We've just a part of it. P of E is greater than or equal to 0. It can be 0 or it will be greater than 0. Is that correct? Children?
Ma'am, could you please repeat that one more?
Sure. P of E, the probability of the happening of an event, can it be 0?
Yes,
No, ma'am, it can't be 0.
Yes, ma'am.
Okay. Can it be anything more than 0? Not at the same time. The probability, if it is 0, it cannot be 0 and more than 0 at the same time. It will be greater than or equal to 0. The probability of the happening of an event is equal to 0. Yeah. It's greater than 0. Okay. So P of E greater than or equal to 0. But when you exchange this, it will be 0. When you write 0 here and P of E here, you must reverse the inequality. It will be like this. 0 is less than or equal to P of E. Let me finish it. Then you can ask me a doubt. See here. The probability of the happening of an event can be 0, can be equal to 0 or anything greater than 0. That is the first thing. When you reverse, okay, the other one is the probability of the happening of an event can be 1 or less than 1. These are the two conditions together. See both P of E is equal to 0 or greater than 0. Correct. P of E is equal to 1 or less than 1. Correct. We'll have to put these two together. Okay, so to put these two together, what we do is we write the 0 here and we write this P of E here. Then the inequality is reversed. This inequality is reversed. Write this one as it is. Write this one as it is. Now write them together. 0 is less than or equal to P of E. Again P of E, no, less than or equal to 1. I've done my part. Now you have to ask me if you don't understand. I wrote both the conditions first. Maybe I can do it again.
Ma'am, how can the probability of happening of an event can be 0?
For an uncertain event. The probability of an uncertain event, of an impossible event is 0. Now you define an event. The event of getting a number greater than 7 on rolling a die is an event, right? The probability of the happening of that event is 0. You define an event E, wherein that particular year has 366 days. $367 days. How many days are there in a year? 365 and a quarter, and in a leap year there are 366, right? Okay, so 367 days. You define an event. The event you have defined is the probability that, okay, the event is the event of a year having 367 days. That's the event. Now the happening of this event, that some year which has already occurred in the past or is going to happen in the future, will have 367 days as an impossible event. So its probability is 0. You define an event that any year selected at random has at least 365 days, has at least 365 days, has at least 365 days. Every year has at least 365 days, every year. It's a sure event. 1 is the probability. Did I answer your question, Shreyas?
Yes, ma'am, I can understand.
All right. So the probability of the happening of an event, the probability, so you define, it's an impossible event, but you define. Now, the probability that, you know, a pack of cards has 5 jacks in it, 5 jacks. The probability that a pack of cards has 5 jacks in it. No, there are only 4 jacks. So 5 jacks in a pack of cards is an impossible event. So you define the event. The event that a pack of cards has 5 jacks in it. That's not possible. It's an impossible event. So the probability of the happening of an event can be 0 or anything greater than 0. At the same time, the probability of the happening of an event can be 1 or anything less than 1. Put these two conditions together. So when you write 0 first and then P of E, the inequality is reversed. It becomes less than or equal to. Here P of E is less than or equal to 1. Now write it as a combined inequality. 0 less than or equal to P of E is less than or equal to 1. This P of E, this P of E. So 0 less than or equal to P of E is less than or equal to 1. This means, this inequality means that the probability can be 0, equal to, no, so it can be 0, equal to, so the probability can be 1 or anything between 0 and 1. Now, is this correct? What's the mistake in this? What's the mistake in this inequality with respect to probability? Okay, I don't want to waste time. So it's less than or equal to 0 less than or equal to P of E is less than or equal to 1. Both the places we have equal to, less than, equal to. Be careful with that. Take a screenshot. Just take a screenshot and read this for yourself. Yes, children. See the first question. 3 coins are tossed simultaneously 200 times. 3 coins. Children, am I audible? And if I'm audible, am I clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. Thank you. 3 coins are tossed simultaneously 200 times. Okay, so you have 3 coins in your hand. 3 coins you have. You toss them simultaneously. Or if you think I cannot toss 3 coins simultaneously, 3 of you will just assume that 3 of us have 1 coin each. 3 of us have 1 coin each. There are 3 people. Each of them have 1 coin. And they toss the 3 coins. So they'll toss their coins. All of them will toss it simultaneously. And the coin will land on the ground, right? Or on the table, wherever. What are the possibilities? All the 3 coins can show 3 tails. All the 3 coins can show 3 tails or 3 heads, or there can be 1 head and 2 tails. So like this, 3 coins are tossed simultaneously 200 times and the outcomes are recorded. I'll tell you, I'll explain how they're recorded. They're recorded like this. If the outcome has all 3 heads, or only 2 heads, or only 1 heads, only 1 head, or no heads at all. That's what is meant by 3 tails. 3 tails means all the 3 are tails. That means 0 heads. Three coins are tossed simultaneously 200 times. That is, so three of us. We have 1 coin each in our hand. We toss the coin. All of us, all the 3 of us, toss the coin simultaneously. The coin lands on the ground, and we record the outcome. How on what's the criteria? We look at the outcome like this. Does the outcome have all 3 heads, or only 2 heads, or only 1 head, or no head at all? Three heads, 2 heads. That is 3 heads meaning all the 3 coins showing heads. 2 heads meaning 2 coins show up heads and 1 coin shows up tail. 1 head meaning 1 coin of the 3 coins, 1 coin shows head. The remaining 2 coins show tails. 0 head meaning all the 3 coins show tails. See, answering the probability, questions may be easy. Please understand the table. Like this, these 3 friends toss the coins 200 times. So probably summer vacation, they wanted to spend time. So they've been tossing 3 coins simultaneously 200 times. and they've recorded the outcome. So they made a table like this first. They already made a table like this first. What table they made? So they called it outcome. Outcome of getting 3 heads, 2 heads, 1 head, no heads. And the frequency, the number of times it happens. So supposing now they toss the coin. They toss the coin. Okay, the 3 coins. I'll just write HT. Okay, you will not find HMT on the coins. You know, you will find the number or otherwise the lines. So you know what heads and tails mean in a coin. I'll just write HMT. You will not find HMT on the coins. So supposing it is like this. Supposing it's like T, T and H. So this is 1 head. So I'll put a tally mark here. And now I toss it again. I toss it again. H, H, T. 2 heads. So I put a tally mark here. Again I toss. I mean, not I. The 3 friends toss again. The 3 friends toss again. All the 3 tails. That means 0 heads. They put a tally mark here. Again they toss. They toss the 3 coins. So say H, H and T. Or H, H and H. All the 3 coins show heads. So 3 heads this is. So here one frequency. Like this they go on 200 times. So they would have put the tally marks first, like this, tally marks first. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, like this. So 23 times of the 200 times, out of 200 times, 1 second. Out of 200 times, because totally they toss the 3 coins simultaneously for 200 times. 1 second. Yeah. 23 times. All the 3 coins show heads. 84 times. See, when you add all these, you should get 200. You should get 200. When you add 23 plus 84 plus, please check that, okay? It should be 200. Otherwise, the data is incorrect. It should be 200. So 23 times all the 3 coins showed up heads. 84 times 2 coins showed heads and 1 showed tails. That is what is 2 heads. It's understood, no, there are 3 coins. 2 heads means you will wonder what about the other coin? 1 tail. 2 heads meaning the other coin has showed up tails. 1 head, 71 times. 1 head meaning only 1 head. That means the remaining 2 coins showed up tails. 3 tails. All the 3 showed tails. All the 3 showed tails. That means no heads. No heads. 22 times. Three heads means 3 heads and 0 tails. 2 heads means 2 heads and 1 tail. 1 head means 1 head and 2 tails. 3 tails meaning 0 heads and all 3 tails. You can make a note of that. You don't see it in the question. I'll write it again. 3 heads meaning all the 3 are heads. No tails. 0 tails. Oh, 0 tails T. 2 heads meaning 1 tail. 1 tail. 1 head meaning 2 tails. 3 tails. All the 3 are tails meaning 0 heads. 0 heads. 0 heads. So many times. Now answer the question. Find the probability of getting 3 heads. How many times 3 heads? 23 times. 23 times 3 heads. Out of 200 times. So this 23 is the favorable outcomes. Number of outcomes favorable to the happening of this event is 23. Total number of outcomes 200. Number of outcomes favorable is 23. Total number of outcomes 200. So 23 by 200 is the probability of getting 3 heads. Now you understand, you can answer the rest of the questions. No heads. No heads is the last one. 0 heads. 22 by 200. No tails. 0 tails. The first one. 23 by 200. At most 2 heads. At most 2 heads means, at most meaning maximum 2 heads. At most 2 heads meaning maximum 2 heads. At least what do you mean by at least? If you say you want at least two chocolates. At least 2 chocolates meaning, see, supposing you say I want at least 2 chocolates and I give you 5. You'll be happy because you want at least 2. So I can give you 2 or anything more than 2. You're happy. At least 2 means 2 or anything more than 2. At most 2 means 2 or anything less than 2. So at most 2 heads meaning maximum 2 heads. 2 heads, 1 head or no heads. Let me write it here. At least 2 heads means 2 heads or more than 2 heads. More than 2 heads. At most 2 heads means 2 heads or less than 2 heads. So 2 heads or less than 2 heads means 2 heads, 1 head, no heads. No heads also. No heads also. So here it is 2 heads. Here it is 1 head and 3 tails meaning no heads, 0 heads. 2 heads, 1 head, no heads. So 84 plus 71 plus 22. This total is the number of favorable outcomes. What is 8? Please add that, okay? 84 plus 71 plus 22. Whatever is the sum divided by 200. Is the probability of getting at most 2 heads. Is the probability of getting at most 2 heads. Please work this. Please write down this question and work this. Children, please write down the question and make a note of the meanings of the terms at least and at most, as explained above. At least 2 heads, at most 2 heads. Done, children? Have you written the question? Please respond.
Yes, ma'am.
Oh, there are 14 of us and only one voice. Hitesh, Ananya, Deepika, Tarun, Shivani, Vasudevan, Nikita, Nivedita, Pratiksha, Pranav, Sangamitra, Satvika, Shreyas and Tarun. Tarun, you have logged two different devices, huh? Tarun Ishwaran.
Yes, ma'am.
Why?
Ma'am?
No, why? Why have you logged in two different devices?
I'm only in one device, ma'am.
Oh, I can see your name twice.
1 minute.
I can see your name twice. Okay. Children, kindly tell me, have you copied the question?
Yes, ma'am.
Yes, ma'am.
Okay. Here you go with the answer. This is how you present the answer. How do we read this? Probability of getting 3 heads. P of getting 3 heads. Probability of getting 3 heads. P of getting no heads. P of getting no tails. P of getting at most two heads.
Ma'am, can we name the event and as A, B, C, or E1, E2, and then put P of A or P of E1?
I've also, there are answers where I have presented like that. I'll show you that screen now. Was it Ananya?
Yes, ma'am.
Yeah, you can do that. You can define the event. Let A be the event of getting 3 heads. Then you can say P of A.
Okay, ma'am.
Okay, please, you can do that. You can do that. Let me tell you that also. Please write down this. Or if you've understood it, the other method, as Ananya said in school, you can also, write this answer in your way. Let me tell you that. So you can define the events. Children, this is very important. Please make a note of this one, 3 heads, 0 tails, because 2 heads means 2 heads and 1 tail. 1 head means 1 head, 2 tails. Please make a note of this. Understand this one. Okay, so we could define the events like this. Let say A be the, let A be the event. Let A be the event of getting, let A be the event of getting 3 heads. Then P of A is equal to, define this one as an event. Let A be the event. Let A, you can use any letter. You can say A, you can say E1, E2, E3, E4. Capital letter, no small letter. So you can say let X be the event of getting whatever. So let A be the let A be the event of getting 3 heads. Then P of A, you've defined this, right? You've defined this, you've given the letter A. So then P of A is equal to whatever is the answer. What is for 3 heads? 23 by 200. You can present everything like this. Then define the next event. Let B be the event of getting no heads. Let B, capital letter B, be the event of getting no heads. Then P of B is equal to 22 by 200. We can also do that. I have not defined the events. I have directly written like this. Both are fine, but please go with your school teacher's method. If she's defined the events, please define the events. Any questions, children? Ananya, thank you for like reminding me about the alternate method. I should have mentioned it. I have it in somewhere behind. I've done it. Let me just check. Yeah, see here. That even be the event that tire will be replaced. Not everywhere I've done that. In a few sums I've defined the events. You can see it here. Let even be the event of event that a tire will need to be replaced before covering 4,000 kilometers. Thank you, Ananya. Good that I mentioned it here itself. So you got to know both the presentations. Yes, any questions, children? Yes or no?
No, ma'am.
What about the others? Thank you, Shreyas. What about the others? Any questions?
No.
Okay, please get the difference between at least and at most. At least two heads means two heads. So in this situation of tossing three coins simultaneously, at least two heads meaning two heads or three heads. Because only two, three, right? More than two is only three. You cannot say four heads because here they're tossing only three coins. So at least in this situation, at least two heads includes two heads and three heads. At least two heads, at least two or more than two. So two heads, three heads. At most two heads, we have to be careful. Means two heads, one head, no heads also, because that also is less than two. Here at most, the last one. At most two heads, the last one. At most two heads meaning two heads. Where are two heads here? Two heads, one head, no heads. All this satisfy at most two heads. At most two heads meaning two heads or anything less than that. One head, no heads. 84 plus 71 plus 22. 177 by 200. If it is at most one head, it means one head, zero heads. These two together. At most one head meaning one head or anything less than one head, zero heads. Okay, children, I hope it's clear. In a single throw of two dice, die is singular, dice plural. Die, D-I-E, die. D-I-E, die is singular, dice plural. In a single throw of two dice. So you have two dice in your hand. You throw it once. You throw it up once. In a single throw of two dice. What is the probability of getting a sum of 9? And what is the probability of getting a doublet? In a single throw of two dice. So when you throw two dice, what are the possible outcomes? You can get one on the first die and one on the second die. That is with one on the I think I have 1 second. Let me write it for you. So when you throw two dice simultaneously, let's see the outcomes, possible outcomes, with one on the first die. With one on the first die. Okay, let me just write and then talk. All right. So with one, so maybe the first, see, you have two dice. You have two dice in your hand. You throw it only once. You throw them up only once. What are the, so you throw them up once. So the two dice, they land and you can see the outcome on the face of the two dice. Now, what are the possibilities? What can be the outcomes? What are the possible outcomes? What are the possible outcomes when you throw two dice simultaneously? Okay, so here are the outcomes with one on the first die. So maybe one die you know, one of the two dice, or we'll say the first die, second die. Okay, maybe the first die shows 1 and the second die also shows 1 or 2 or 3 or 4 or 5 or 6. With 1 on the first die, you can have 1, 2, 3, 4, 5, 6 on the second die. With 2 on the first die, you can have 1, 2, 3, 4, 5 or 6 on the second die. With 3 on the first die, you can have a 1, 2, 3, 4, 5, 6 on the second die. With 4 on the first die, you can have a 1, 2, 3, 4, 5 or 6 on the second die. With 5 on the first die, you can have a 1, 2, 3, 4, 5 or 6 on the second die. With 6 on the first die, you can have a 1, 2, 3, 4, 5, 6 on the second die. So this covers all the outcomes, all the possible outcomes. You cannot have everything in that one outcome. That one outcome can be any one of these 36 outcomes. Nothing beyond this. You cannot have anything out of this. You cannot have anything out of this one. So you have 36 outcomes here. So when you throw 2 dice simultaneously, you can have 36 possible outcomes. Any one of these 36 possible outcomes. It can be a 1-1, it can be a 1-2 or a 1-3 or a 1-4 or a 1-5 or 1-6 or 2-1, 2-2, 2-3, 2-4, 2-5, 2-6, or it can be 6-3, 6-4, 6-5, 6-6. Any one of these 36 outcomes. Now, what is the probability of getting a sum 9? So you can define the event. Let A be the event of getting a sum of 9. Let A be the event of getting a sum of 9. Then P of A is equal to. So which are the outcomes where we get a sum 9? Sum 9. That means 3 plus 6, 9. Sum 9 meaning exactly 9. 3 plus 6, 9. 4 plus 5, 9. 5 plus 4, 9. 6 plus 3, 9. Where else do we get 9? Where else do we get 9? In the first 2 rows, you cannot get 9. In the first 2 rows. In the third row, the last one, 3, 6. In the fourth row, 4, 5. In the fifth row, 5, 4. In the sixth row, 6, 3. So these are the favorable outcomes. Of the 36 outcomes, these are the favorable outcomes. Sum 9, 1, 2, 3, 4. So 4 out of 36. There are 36 possible outcomes and the outcomes favorable for the happening of your event. The number of, not the probability, the number of outcomes favorable to the happening of your event is 4. So 4 out of 36 is the probability, or 1 by 9. What is the probability of getting a doublet? Doublet meaning both the dice show the same number. Doublet 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 6 favorable outcomes out of 36. 1, 1 is one outcome. 2, 2 is one outcome. 3, 3 is one outcome. 4, 4 is one outcome. 5, 5 is one outcome. 6, 6 is one outcome. So totally we have 6 outcomes favorable to the happening of this event of getting a doublet. So 6 out of 36. Totally there are 36 possible outcomes. So 6 out of 36 is the answer for the second one, or 1 by 6. You can define the event. Let B be the event. Let B be the event of getting a doublet. Then P of B is equal to 6 by 36, or 1 by 6. Children, please write down the question. Class, use the emoji, raise your hand. Ananya, Sangamitra, Satvika, Nivedita, Shreyas, Nikita, Vasudevan, Hitesh, Deepika, Shivani, Tanu. Okay. Good. Yes, children, please write down the question. Is it over, children? Completed?
Just a minute.
Yeah, okay.
Completed, ma'am.
Yeah. These are the possible outcomes. The number of possible outcomes, 36. Number of possible outcomes, 36. What's the next question? You can see a table showing the weights and number of students. Find the probability that weight of a student in a class is at most 60 kgs. The weight of a student in the class is at most 60 kgs. So what is at most 60 kgs? 60 kgs or anything less than 60 kgs. At most 60 kgs meaning 60 kgs or less than 60 kgs. So 60 kgs. Less than 60. Because 61 to 65 kgs is more than 60 kgs. 66 to 70 kgs is more than 60 kgs. This is also more than 60 kgs. This is 56 to 60 kgs. At most 60 means 60 or less than 60. 60 or less than 60. So all these are less than 60. 60 kgs. All these are less than 60 kgs. So 9 plus 5 plus 14 plus 3 plus 1 plus 2. Divided by the total number of students here. Divided by the total number of students here. At least 36 meaning 36 or more than 36 and not more than 50 kgs. Not more than 50 kgs means it should not be more than 50. So if it's more than 50, it's not favorable. It should not be more than 50. So again, it can be 50 or less than 50. It should not be more than 50. So it should not be 51, 52, 53. It should not be that. 50 or less than 50. 50 or less than 50. Please watch this, children, and see if you understand. Any questions, get them clarified.
Ma'am?
Yeah?
Ma'am, is it compulsory to write the answer in decimal form, ma'am?
No, it is not.
Okay.
But I think in NCRT you'll find the answer in the decimal form, right?
Yes, ma'am.
What has your teacher instructed? Because I think writing it in the decimal form is just time sucking. What you can do is you can leave it as a fraction 17 by 19, say for example, and then if time permits, you can find the decimal value.
Okay, ma'am.
Yeah, what is your teacher instructed?
Ma'am, she said it's okay if it's in decimal, also if it's in fraction also.
Yeah. You can leave it as a fraction. You can leave it as a fraction. But if you want to be extra safe, if time permits, don't spend time on division. You can finish the paper and come back to the division later.
Yes, ma'am. Thank you.
Yeah. Is it over, children?
Yes, ma'am.
Yes, ma'am.
Do we understand at most 60 means? You'll have to add up all the frequencies with 60 or less than 60 kgs. At most 60 kgs means 60 kgs or less than 60 kgs. So this class interval, in this class interval, there are 9 students whose weight maybe 31 kgs or anything more than 31 kgs and less than or equal to 35 kgs. Can be 31 or 35 or anything between 31 and 35. 9 students, the weights of 9 students is in this range. Can be 31 kgs or 35 kgs or anything between 31 and 35 kgs. At most 60 kgs or less than 60 kgs. 60 kgs or less than 60 kgs. So add on. At least 36. At least 36, meaning 36 or more than 36. So here is 36 or more than 36. 36 or more than 36. Divided total children. The total is 9 plus 5, 14, 14 plus 14, 28, 28 plus 3, 31, 32, 33, 34, 34, 36, 38. The total is 38. The total number of students, 38. So everywhere 38 will be the denominator. Only the numerator will change. At least 36 means 36 or anything more than 36. Not more than 50 kgs, not more than 50. It should not be, so it should not be more than, it should not be all this. It should not be more than 50. So not all this. That can be all this. Understood, children? Can we go to the next one?
Yes, ma'am.
Yeah. Read this question and answer the. Read the information given and answer the questions. So 200 telephone numbers were selected from a telephone directory. From a telephone directory, 200 telephone numbers were selected at random. So now my number, my telephone number. See, to understand this telephone directory, I don't know the updated directories, but when I was like you, the directories had only landline numbers, not the mobile numbers. Not the mobile numbers, only the landline numbers. I don't know how a telephone directory looks now. So telephone directory, so say my landline number is 0431 2741729. Okay. This is my landline number. So back then there was only one, telephone connection, BSNL. All of us had the BSNL connection. So this is my number. It ends with the digit 9. So like this, 200 numbers were selected from a telephone directory. 200 telephone numbers were selected. So obviously the telephone number can end with the digit 0, or it can end with the digit 1, or it can end with the digit 2, or 3, or 4, or 5, or 6, 7, 8, 9, or 0. The telephone numbers can end with a digit, that is the units digit. Can be a 0, can be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. So of the 200 telephone numbers selected, 22 telephone numbers ended with the digit 0. That is the last digit, ended with the digit 0, or the units digit was 0. 26 telephone numbers. 26 telephone numbers had 1 in the end, had the digit 1 in the end. 22 telephone numbers had the digit 2 in the end, like that. So this is on one page. On one page of a telephone directory, there were 200. Okay, I didn't read it correctly. On one page, this is on one page. What I explained is correct. So on one page of a telephone directory, there were 200 telephone numbers. I said 200 telephone numbers were selected at random without reading the information. So on one page of a telephone directory, there were 200 telephone numbers. So the table is regarding the information based on these 200 telephone numbers regarding their digits in their ones place, in their units place. Out of the numbers on the page, a number is chosen at random. So they select one number at random. There are 200 telephone numbers. One number is selected at random. What is the probability that the units digit of the number chosen is 6? Is 6. So totally 200 telephone numbers. So when you add all the frequencies, it will be 200. When you add all these frequencies, it will be 200. 6 in the units place. 14 telephone numbers. 14 telephone numbers. Supposing they say that, a telephone number that ends with a digit 6 is, open for a cash price of 1 lakh. And say your telephone number ends with the digit 6. So you'd be keeping your fingers crossed. So what is the probability that the number chosen will be your telephone number? Your chance is very less. 14, because only 14 numbers end with the digit 6. 14 by 200 is the probability. 14 by 200 is a probability which is very small. You may get the prize, but the probability that you will get it is very small because the number of favorable outcomes is only 14 out of 200 outcomes. A non-zero multiple of 3. A non-zero multiple of 3. That is in the units place, In the units place, you should have a non-zero multiple of 3. So it can be a 3, 6, or a 9. 3, 6, or 9. These are non-zero multiples of 3. 3, 6, 9. Multiples of 3. So 3, 6, 9. So add all this. 22 plus 14 plus 20. So 22 plus 14 is 36 plus 20, 56. So there are 56 numbers which end with the digit 3 or 6 or 9. which are all multiples of 3. 56 out of 200 is the probability. Do we understand, children? Okay, Nivedita. Children, see the answer here. So the first one is 6. It will be 14 by 200, which can be reduced to 7 by 100. You can leave your answer there, but since the denominator is 100, it's easy to write it as a decimal, 0.07. Three multiple of 3, so it will be 369. 369. 22, 14, 20. You can see it here, 22, 14, 16. 56 by 200. The denominator is not 100. It will be, when you simplify this, it will be 28 by 100. This is 28 by 100, which is 0.28. Non-zero even number. Non-zero even number. So it will be 2, 4, 6, 8. 22, 20, 14, 16 by 200. Finally, a number whose units digit is an odd number. Units is an odd number. So 1, 3, 5, 7, 9. Add all these frequencies and the denominator with denominator 200. Okay, this may take time to write, children. We'll just do one more. Please take a screenshot of this one. Please take a screenshot of this one. An insurance company selected 2,000 drivers at random in a particular city To find a relationship between age and accidents, an insurance company selected 2,000 drivers at random in a particular city to find a relationship between age and accidents. That is, if accidents increase with age or decrease with age. Okay, they wanted to find a relationship between age and accidents. The data obtained are given in the following table. So you can see that age of the drivers in years, age 18 to 29, 30 to 50, above 50. Accidents in 1 year, 0 meaning no accidents, 1 meaning 1 accident, 2 meaning 2 accidents, 3 accidents, more than 3 accidents. So how do we understand this information? Totally, when you add all these, when you add all these numbers, when you add all these numbers, that will total to 2,000. It will total to 2,000. There are 440 drivers who have not met with any accident in this age group 18 to 29. Age group 18 to 29. No accidents, 440 drivers. Age group 18 to 49 with no accidents, 440 drivers. Age group 18 to 29. 1 accident, 160 drivers. Age group 18 to 29. 2 accidents in 1 year, 2 accidents, 110 drivers. Same age group, 3 accidents in 1 year, 60 drivers. Same age group, more than 3 accidents, 36 drivers. So like that, above 50 drivers, above 50 years of age. No accident, 360 drivers. 1 accident, 45 drivers. 2 accidents, 35 drivers. 3 accidents, 15 drivers, and more than 3 accidents, 9 drivers. Find the probability of each of the following events for a driver chosen at random from the city. So out of these 2,000 drivers, 1 driver is chosen at random. You select 1 driver at random. Find the probability of each of the following events for a driver chosen at random from the city. That is, the driver is being 18 to 25 years, 18 to 29 years of age, and having exactly 3 accidents in 1 year. So it should satisfy. So the thing is, here there are 2 conditions. That's all it is. Here there are 2 conditions. One condition is related to the age. The other condition is related to the number of accidents. So while you find the probability, you must consider both the conditions. Age group 18 to 29, exactly 3 accidents. Age group 18 to 29 and exactly 3 accidents. So search here, age group 18 to 29, exactly 3 accidents. $60 by 2,000 is the probability. 60 by 2,000. 30 to 50 years of age and having 1 or more accidents in a year. 30 to 50 and having 1 or more. 1 accident or more than 1 accident in a year. So that means, see, this is 30 to 50. This is no accidents. This will not come. 1 accident, 2 accidents, 3 and more than 3. See this one, all these numbers are for drivers in this age group 30 to 50. 505, no accidents. But here they're saying the second condition, first condition 30 to 50 years, 30 to 50 years. And the second condition is 1 or more accidents. 1 accident or more than 1 accident. So that means this will not come. 0 accidents will not come. 1 accident and more than 1. All this. So add all these numbers 125 plus 60 plus 22 plus 18, whatever it is, by 2000. The last one has only one condition. There are no 2 conditions there. Having no accident in 1 year. That means for the age group there is no condition. Which means you should consider all the age groups. Because if they say 18 to 29, you should take only 18 to 29. If they don't say anything, you can choose. I'm sorry, you have to take all the 3. Not choose, sorry. If it's given, if they have specified, you should take only that age group. Nothing is specified, all the age groups you should take. Having no accidents in a year. So no accidents, no accident, no accident, no accident. Now you will think, no accident, but age group, it's not mentioned, so you can take it. No accident. Age group not mentioned, so take it. No accident. Age group is not mentioned, so take it. So 440 plus 505 plus 360 divided by 2000. Is that okay, children? See, I chose to, one thing is, I just wanted to revise a few sums today. And the second thing is, when I ask you questions, I'm not getting prompt responses. So I thought, I'll explain the question and answer it myself as if I am a student and I'm going to write the exam. But I only pray the session is useful. Is that fine, children? You did not answer. I did not ask you any question. At least answer yes or no. Have we understood?
Yes, ma'am.
Yes, ma'am.
All right. 1, 2 responses. Thank you.
Yes, ma'am.
Very good. Thank you. Yeah, take a screenshot, children. I'll show you the question again. Please take a screenshot.
I'm took, ma'am.
Yeah. Just what we understood. So here, as Ananya rightly, reminded me, I've defined the events. You can see I've defined the events and then found the probability. Let E1 be the event of choosing drivers of age 18 to 29 years with exactly 3 accidents in 1 year. Then P of E1 is equal to you can see it there. Is it fine, children? I think you responded earlier. Yes.
Yes, ma'am.
Yeah, read this one and answer the questions. We'll wind up today's session with this one. Anyone can answer the first one?
And 6 by 80, 3 by 40.
First one, is it?
Yes, ma'am.
Less than 15%. 6 by 80 or 3 by 40. Very good, Ananya. Less than 15%. So when it is 0 to 15, 15 to 30, 0 to 15 does not have 15 in it because 15 is included here. 0 to 15. 15 is not because it's the class intervals are continuous. So 15 is not included here. 15 is included here. Less than 15 marks. Since 15 is not included here, this class interval has marks less than 15. 15 is not included here. It's included in the next one. So 0 to 15 has marks less than 15. So 6 by the frequency, the number of students is 6 by the total 80. 6 by 80 or 3 by 40. Next one.
Ma'am, 16 by 80.
How do you get the value in the numerator? What should you do?
Ma'am, 60 or more marks, so we have 16, ma'am, divided by the whole students, 80.
Was it Shivani?
Yes, ma'am.
Shivani, how much you said in the numerator?
Ma'am?
No, the numerator value, I didn't get it clearly.
Ma'am, it's that the question is 60 or more marks, and ma'am, so we should see that between 6 and 75, ma'am. So 16 divided by 80 total students.
Okay. Okay. Is this, can you take this one for 60 or more than 60?
We have to add 16
We have to add 16 and 4, ma'am.
Yeah, you have to add 16 and 4. 16
20.
and 4 plus 60 marks. This 60 marks or more than 60 marks. 60, this is 60. 60 is here. More than 60. Here also more than 60. Above 75 is also more than 60. 16 plus 4 by 80. That is 20 by 80 or 1 by 4. Less than 45 marks. Less than 45. Should you take this one? Less than 45.
Ma'am, we should add 6, 13 and 17, ma'am.
Yeah, 6, 13 and 17. Only these three. Because not this one. Less than 45. These three class intervals have values or have marks less than 45. So that will be
36 by 80, ma'am.
36 by 80. 36 by 80. That reduces to 4 9s are 36, 4 20 times 9 by 20. Take a screenshot, children. You can see the question and answer here. Take a screenshot. Okay, can the probability of the happening of an event be 225%? Can the probability of the happening of an event be 225%? Can it be 225%, children?
No, ma'am, because the maximum marks is only 100.
How do you express 225% as a fraction?
225 by 100.
By 100. Simplify that. 225 by 100. 25 tables in the tables of 25. 25 nines are 225. 25 fours are 9 by 4. So since it's an improper fraction and its value is greater than 1, 9 by 4 cannot represent the probability of the happening of an event. Or 225. 225 cannot represent the probability of the happening of an event because its value as a fraction is 9 by 4, which is an improper fraction. And since the probability cannot be more than 1, improper fraction, the value is more than 1. Can it be negative? No. Probability cannot be negative. Probability cannot be more than 100% because 100% is 100 by 101. Sure event. All right, children. That's it for today's session. Thank you so much. At the end of the meeting, we have Ananya, Sangamitra, Vasudevan, Deepika, Shivani, and Tarun. Thank you, children. Good night.
Thank you.
Thank you. Thank you. Good night.
Thank you.
Thank you. Good night.